Here's a real brief review of our unit on electricity. Hopefully this will get you ready for tackling the problems and the concepts for the Unit 6 test on electricity. Okay, so we want to start out with your circuit basics. So our terminology, how things come about, the schematics. So you can see a battery schematically, and then a battery in real life. Okay, one of the first battery cells where we have our different metals inside our acid. We see wires and we see a light bulb. We also added a current meter, a fuse, and a switch on our schematic circuit. So you want to remember these terms. Voltage. Voltage talks about energy. It tells you how much energy you're going to have per coulomb of charge. So think of it as energy, but it's energy per charge, not total energy. Okay, the voltage is determined by the type of chemical reactions going on in the battery. And remember, voltage is something that you gain in a battery and you use up in things like light bulbs and speakers. Okay, the units again, volts, joules per coulomb. The next term is the term current. Current refers to the flow of charges through your circuit, and specifically it tells you how many charges are flowing per second. Current in amps is equal charge in coulombs per second. Okay, again, it's talking about the flow of the electricity through the circuit. And then we finally have power, which is going to tell us how bright our lights are, how loud our speakers are, how fast our motors are, etc. It's our important term. And the power tells you how much energy you're getting each second. That's going to be measured in watts. Finally, I hope you can see that if you multiply voltage and current together, the charge cancels and you're left with energy over time. So voltage times current is equal to power. So these are three of our basic electricity terms: voltage, current, and power. Voltage again is created in the battery, used up in things like the light bulb. The current is the flow of the charges through the circuit, and the power is the energy that you're using up each second. Okay, then we had the term resistance, and we looked at resistance of things like wires. And you want to remember that the resistance of the wire depends on three factors: what it's made out of, how long the wire is, and what is the area that the charges are able to flow through. The material, you can look up on your purple sheet. Length should be in meters, and area is going to be in meters squared. Again, you want to remember that to get your area, you do pi times the radius in meters squared. Sometimes your wire will be indicated by a gauge number. Make sure you take that diameter, turn it to a radius, turn it from millimeters to meters before you plug it into your equation. We also have objects called resistors. Resistors are designed to have a certain resistance, and then it's set up to give us a certain flow of electricity to different parts of our circuit. The schematic symbol for a resistor, the colors for a resistor. Remember, the first two colors just give you numbers, so it would be 2, 5, red and green. The third band's the most important one because that will tell you, are you in the hundreds, the thousands, the millions. In this case, it's orange, which is 3, so it would be 2, 5, followed by 3 zeros. 25,000 ohms. The fourth band is used for telling you what kind of tolerance or error you're going to find in your resistor. Gold says you could be off by up to 5%. Silver means you could be off by up to 10%. Then we had Ohm's Law, which links together our terms of voltage, current, and resistance. Voltage again comes from the battery. The resistance is going to come from either your light bulb or your speaker or whatever you're powering. And then to find the current, you look at the relationship between current and voltage. More voltage will be able to push more charges through your circuit, and more resistance will inhibit the flow of current. So that will be an inverse relationship. Together, we get the formula known as Ohm's Law, which says the current in amps equals the voltage in volts divided by the resistance in ohms. Bigger values for voltage give you bigger current. Bigger values for resistance give you smaller currents. You should remember that batteries sometimes are labeled with ratings, either amp hours or watt hours, sometimes both. Amp hours, remember, is going to be coulombs per second times 3,600 seconds. The seconds are going to cancel. So amp hours is a way of telling you coulombs. It's a way of telling you how much charge is on the fully charged battery. Watt hours is going to be joules per second times 3,600 seconds. Seconds again cancel, and watt hours will tell you how many joules will be on your battery. So watt hours tells you the energy storage, and the amp hours is a way of telling you the charge storage for your battery. Okay, you want to remember the difference between series circuits and parallel circuits. Series circuits are ones in which you have only one path for electrons to flow, and a parallel circuit gives you multiple paths for the electrons to flow. When you're attacking a series circuit, start by adding up all of your resistances. You're going to do that because the electrons have to travel through every single one of these things. Okay, so you get your resistance total by adding up all your resistors. You could then find your total current by using your total voltage, that is your battery voltage, and dividing by whatever you got for your total resistance. Once you have your total current, since you have only one path, all of the currents will be the exact same number. So whatever you get as your total, use that current at each resistor. So whatever you got here gets plugged in, then you plug in 4 different times, 23, 44, 59, and 95 to get the voltages on resistor 1, 2, 3, and 4. Once you got all those voltages, you can find your powers. And you'll get your powers by taking the voltages and multiplying by your currents. When you have a parallel circuit, if you wanted to find the total resistance, you do not add them, you add the reciprocals. So you do 1 over 900 plus 1 over 270 plus 1 over 180. Get an answer, and then take the reciprocal, and that would give you the total resistance of that circuit. You don't have to do that in many cases. In many cases, you just start with the fact that if you have a 9-volt battery, since all the paths are independent, all the paths are going to get the exact same voltage. So then you can find the current for each path, and then the power for each path. Okay, if you had to get your total current, you add up the current in 1, plus 2, plus 3, and you do that for however many branches to this parallel circuit you happen to have. Okay, and that'll get your total current. You could then find your total power with your total volts and your total current. Remember, with the series circuit, if you have a break anywhere in your circuit, it shuts the entire circuit down. In a parallel circuit, if you have a break in one of your branches, it only shuts that one path down. Okay, the other paths would continue to flow. Obviously, if the break was down here, it would shut off the entire circuit. Okay, so a quick summary of some of the main ideas that we ran across with our electricity unit. Here are all your symbols. You don't have to memorize these. You have a reference sheet where all of these are present and available to you. So good luck on your concept part and good luck on the math part. If you'd like to set up a formula sheet, here are all the formulas that we just talked about.